Thank you for joining me, and thanks for coming to this session. It should be interesting, and we'll have plenty of time for Q&A after. My name's Jonah Cowell. I'm VP Market Development and Insights at AppDynamics. What I do at the company is essentially run product strategy. I work for Bhaskar, the CTO. Some of the other things I do is a lot of public speaking, thought leadership, that type of thing. So what I'm going to talk to you today about isn't directly related to AppDynamics. It's a lot of the greater trends in the industry. Obviously, my background is in monitoring, and that's where a lot of my passion comes from, so that's going to factor into the talk today. I'm going to start out, obviously, we have our general disclaimer, legal. Next. So a little bit about where I came from is I'm an IT operations professional. That's what I did for 17 years. I worked at many different startups, a couple acquisitions, worked at large banks, and ran awesome tools and technology to make sure that the business was up and running. So this is what we think we do. We have these control centers. I like there's no keyboard here because we don't need keyboards. It's all virtual. And you know, we have all this infrastructure that we manage and that we build, and everything's clean and nice, and you know, we really engineer things. But in reality, a lot of what we deal with looks a bit more like this. And I wish I had some of the pictures of the data centers earlier in my career, where I did in fact have fans to make sure things were working properly in the basement of a house in Cambridge as we did a startup. I was always kind of a little bit of a anti-Linux person in my days in IT operations, and I was a committer in the FreeBSD project, so some of the networking code that you still see are things that I wrote in terms of the drivers. But you know, everyone evolves, and eventually we all learn to get along. So I embrace and like Linux today, just like most of you, even though we've changed. And look, even Microsoft likes Linux now. So who would have thought that was going to be an actual picture of Microsoft a decade ago? So everyone evolves, everyone's cooperating, everything is about openness, and things are just changing in general. And after I was a practitioner for a while, for 17 years in ops, I went over to Gartner. I was a research VP there. So most of the research that you read up until 2 years ago in the monitoring space, I wrote. So I did all the Magic Quadrants, network performance, application performance. And you know, the famous Magic Quadrants typically look more like this than the ones that you read. It's always a challenge. People love you, people hate you, that's how it goes. But writing research is really fun. I enjoyed it a lot, talking to thousands of end users a year, learned a lot about the industry, the challenges people face, and then joined AppDynamics nearly 2 years ago. And it's been quite a ride. Great technology, great company, great culture, and I've enjoyed it immensely. So moving into a bit more about the content and what we're talking about here, it's really about the agility and whether you can change or adapt fast enough in terms of your software systems and applications. And what you'll note, and Gartner's even gone further this year in Symposium when you hear about what they talk about, is it's much more about ecosystems and partners, and you're not going to go to one vendor and just buy everything. You're going to end up piecing together a bunch of different technologies. You're building an ecosystem around your company, and it's important to understand APIs and openness are the key to making that work. So what you saw in the keynote yesterday for us was a lot about how we're building APIs first, and then we're building UIs on top of the APIs. And that's a big change. That's what every company is going through today, is really how do we build this open ecosystem in order to drive the agility that we need. Make things swappable, make things into small components that can be changed easily. And I'll talk a bit more about that as we progress. And then there's really interesting things happening in terms of the changes in user interfaces, the changes in computing in general. Gartner has some interesting predictions around the future of IoT and how devices are changing, how we interact with systems are changing. The thing that we've seen as we've been going through our journey in building IoT technology is that we've seen mobile become a real key part of IoT. So mobile is often the gateway, whereas just a couple years ago, a lot of IoT had set-top boxes and other types of gateways. So it's really evolving and changing. We're still relatively early in VR and AR, but it's going to drastically change computing as the technology, the algorithms improve. I'm going to touch on that a bit later about artificial intelligence as well. But all of this has a downside. The need for connectivity and performance is key. I don't know how many times I talk to my smartwatch and I get the trying, doesn't connect. You know, this kind of annoyance happens all the time still. So the need for high quality networks, the need for connectivity that works the right way, and having backups and caching to make sure that systems function better when they're disconnected is going to be key. Because we all know that being connected is great, but sometimes your connections fail. And it's about trying to build in that resiliency and caching. Google's been doing a lot of work on their browser to enable that, a lot of offline modes that when you have little hiccups and microregressions in your application or your connectivity, then it doesn't necessarily affect your workflow as much. So there's a lot of intelligence being just built into general web browsing, being built into all the apps that we use, because this just will kill your user experience. And this kind of thing happens a lot in my experience. How many of you have these like personal assistant connectivity issues? Can I have a show of hands? Yeah, good amount. So this is obviously very frustrating as a user. So we have to do more to enable that better. Now, a lot of vendors will come out there and tell you that technology influences culture. But in reality, that's not the case. The reality is that it's very different. So a vendor will say, buy my tool, use my technology, we will enable you to be agile, we will enable you to do DevOps, we will enable you to make the kinds of changes to your business that you need. But that's not really the case. Your culture is going to influence your technology choices. And cultural change is the hardest thing for organizations to do. I see this in my company. I see this when I talk to other companies that are looking at our solutions. It's a constant struggle. And part of this goes towards whether you're building a centralized or decentralized team. There's a lot of kind of conflicting information out there around how you should structure your teams. Do we want a bunch of different disconnected teams? Do we want centralized tool teams? How do we centralize and decentralize at the same time to get the agility that we need? And it's a big challenge because as a company scales and large enterprise, which most of you are probably part of, you want to centralize and use that economy of scale, but yet you want to build small teams that move quickly, make their own decisions, have accountability. So these often conflict with each other, and it's a really tough problem to solve. I don't think anyone really has a good answer to this because you kind of need the centralized scale and the decentralized type of speed that these small teams provide. And it's really about the culture. It's very hard to make these kinds of decisions, and companies go back and forth. I see it all the time in APM where people try to build a center of excellence for APM, and then they scale that out, but yet you want the teams to own some of the responsibility. So how do you centralize and decentralize? Some of what you saw in the keynote yesterday about license management, how do we carve up the licenses and the permissions so that small teams can implement the technology, but it can be managed centrally because that's what we want to do as a large organization. So that's the real challenge that you see here is how do we kind of handle both sides. And then the other thing that you see is that vendors come in and say, we're just going to sell you DevOps tools. And they totally miss the point. But as consumers of that technology, people buy it. They really think that, oh, I can just go down the street. There's another conference from a company that sells DevOps tools going on here in Vegas. And they will sell you their DevOps tools. And the reality is, it's not the technology, it's how you utilize it, how you organize it. But once again, the integration is key. So how do you piece together all of these different components into a pipeline that makes sense for your culture and the way that your teams are organized and divided? How many of you are familiar with Conway's Law? I like talking about this. Oh, not that many. So, okay. 10%, not too bad. So Conway made this law in the, I believe it was late 60s, early 70s. And he basically stated that the result of what organizations produce is based on how they're organized or how they communicate. And I have a couple kind of slides that we'll go into to explain that. But Conway himself worked on this really archaic language that he kind of pioneered. And the scary thing is that it's still in use in EHR systems. So those of you that are in healthcare or that are familiar with Epic, this is the thing that Conway worked on, is this archaic language that's still, unfortunately, part of our day-to-day lives. So it never really dies. It just continues to persist. He started this in the 60s, and he is still a really bright guy in terms of, professor. And what he said is basically in monolithic traditional organizations, they typically look like this. So you have your UI people, they build the front end. You have your middleware people or your application people, they build the middle tier. And then you have your DBAs, and they own the data store. And the result of this is that the support is the same type of silos. Everything in the organization is the same type of silos. So what you run into is, if you're trying to build cross-functional teams or you're trying to do DevOps in your organization, you essentially run into problems because your organization doesn't match the end result that you're trying to build. And ultimately, if you're trying to move towards microservices, it just causes a lot of problems for you as an organization because you're trying to figure out how to divide out those different silos. And part of microservices is really building this stateless type of architecture. So instead of thinking of your components of the application as individual pieces that you need to care and nurture for, it's more about having them be reusable, and so that you can spin up new instances, spin down new instances. It's about really scaling this out. And the biggest challenge with microservices is how you deal with the data problem. So if I take my big centralized repository, break it into small pieces that live with each service, how do I federate? How do I ensure consistency? These are all major problems that are hard to solve in microservices architectures. And that federation, there isn't really good answers for it. A lot of people will build different types of queuing systems to move data between instances, and it becomes really complicated. And it's not a big deal if you're Netflix, you're streaming videos, who cares if the consistency comes after a minute, but for a bank, that's not gonna fly. You need that consistency immediately, and that's really the challenge with these data architectures is changing the culture and the organization to deal with these new paradigms. And so an example of this is, how do we move from what is on the left, the traditional silos, to what is on the right, which is a microservices architecture. If each team is building their own service, the data needs to live with the service. Otherwise, you get back into the situation where you're waiting on a DBA or someone to make changes to the central store to help your service to do the changes that you need to do. And that's really the challenge, is moving to this type of data architecture. The other piece is that if you want actual choice of your teams, if someone says, I want to write my next service in Go, and it may not be a standard language, as long as they have APIs on top of it that let it interoperate with the rest of your microservices, you shouldn't really care. These are supposed to be easily rewritten. The same thing goes on the back end, is you can pick different data stores as long as the federation layer underneath it works. So a lot of people will build a queue that'll take data and translate it and move it between these different stores. This is very complicated. I mean, that's the challenge with these architectures. But the reuse is key. If I want to try a new technology, a new data store, a new language, you should be able to do so. This just gives you an idea of where microservices are, and you can see the bolded on the top right there, the bolded piece. Gartner builds these hype cycles, which essentially show that there's an initial need for something like microservices. It goes up the inflated peak of expectation, where you think every customer I talk to at AppDynamics says they're moving to microservices. But when you actually start understanding what they're doing, they don't have the answers to actually embrace microservices. And that's because it's such a hype technology, everyone talks about it all the time, that people say, I need that, that's what I want to do. But is your culture ready for the change? That's the real question. So after the peak, people get generally disillusioned. So I think people will realize in the next 3 to 5 years that microservices aren't for everyone. Microservices aren't the answer to agility for every business. And then eventually people will get used to it and they'll say, okay, I'm going to use microservices for my new web apps, my new mobile apps, but I have all this legacy technology that I know I can't change. So what Gartner has kind of started talking about is the concept of mini-services. And what this is they really call it SOA done right, or refactored SOA. And the idea here is kind of fencing. So I take my mainframe application, I build some APIs on top of it, and then I've kind of put it to the side and made it so that I don't have to wait for the mainframe team to make changes. At the same time, there can be public APIs that interface with your microservices architecture or your applications on top. So this kind of design makes a lot more sense. This is something Gartner's been writing about probably for the last year and a half. And this is a lot more what enterprises, when you dig into what are they actually doing, this is what they're actually doing. But they want to use the word microservices so that they are in the trend, so to speak, so that they're building the agility that they need. So the reality is that this type of architecture where it's blended makes a lot more sense. And even in the sessions I heard yesterday, there was, I'm not going to call them out specifically, but there were these types of architectural changes happening where they were kind of fencing and then building services on top of it. So now we get to talk about monitoring a little bit. Sorry, I need some caffeine. So the challenge is, how do you manage all these service-based apps? And part of DevOps is choice. So each team can choose what they decide to use. I feel like using Nagios, I feel like using Prometheus, I feel like using Elk Stack. The idea is that all these teams can pick and choose. And even when you look at large companies that are very agile, like a Facebook or Google, they don't require that teams use their centralized common tools. It's up to the team to choose what they pick from the portfolio that they have. But the problem is that you really need a global view, and all of these teams that are managing individually have a problem with that because they don't have consistent instrumentation or views. And what you run into is, if your services aren't all resilient, or they're not all, they don't all deal with failure gracefully, as our services typically don't in the enterprise, you run into major service problems when you try to do this. And for companies like Facebook and Google, they build their services with resiliency, where the data is decoupled and they're stateless so that they can scale in different ways. That's not applicable to the enterprise, and that's the real challenge. People are trying to get to a nirvana that's just frankly not attainable for most. And that's really where the challenge is. The other piece is that a lot of these services end up being interconnected, and the service boundaries are really hard to measure. And that's where the challenges come into play with managing the end user experience and the service levels. So The end user experience is also tricky because you're managing each service individually. Who's responsible for end user experience? What if the end user's experience is affected by one of the services that's in a chain? How do we measure that? Who's responsible? And when you have all these disconnected separate tools and views, you really miss that big picture. And although everyone is responsible for the end user experience, it's very hard to measure and understand because of the silos in these small teams that are created. And this happens a lot in enterprise where there's kind of a disconnect between each individual DevOps team that's managing a service and the end user experience of the application that's exercising all of these services. So that's where the challenges come into play, and I don't really know that there's a good solution, but we hear from companies all the time that are trying to build these DevOps teams that they almost have to build another team that's responsible for end user experience, which kind of defeats the purpose of having these teams own their individual applications and own the end user experience. So it works great if your apps are decoupled, but in enterprise, you typically have a portal or a login. Underneath that, you have a bunch of applications that use services. So it's much more homogenized than it is, with many of the startups or other smaller applications out there. So, orchestration is the next big thing. Just wanted to ask, how many of you are using Docker in production? So there's pretty good, 8 or 9. So call it 5% of the audience here. I guess how many of you want to use containers in production? Yeah, so that's 30%. I thought it would be higher, but containers are interesting because you can orchestrate them. And the container technology everyone used to really care about a year ago. I'm using Docker, I'm using KVM, whatever types of containers people are using. If you're using, a lot of the open source tools have their own, Rocket containers for CoreOS. It just depends what you're using. And the idea is because they're stateless and they don't own their data, you can spin them up, shut them down, move them around quickly. And the orchestration is really where the key differences are going to come into play. So most people now care less about the container, and they're starting to care more about the orchestration. And so the most common orchestration tools out there, and this is a survey that was put together by the New Stack. Swarm is the Docker native orchestrator. Kubernetes is the Google-backed open source project. And Mesos is another Apache project, which also goes into the Mesosphere enterprise product as well. This one, I like this survey because it was a bit more open in terms of having the choice. A lot of the other surveys, they ask them at Kubernetes conferences, and then it becomes biased because everyone uses Kubernetes. But I like this one because it was a little more balanced. Docker's doing a lot of smart things by building Swarm into the Docker container runtime, making it easier instead of having a whole nother set of services on top of it. But it's interesting to see that there's a lot of people building custom orchestration, whether they're using a private cloud and they're using some other type of orchestration that's maybe part of Pivotal Cloud Foundry or Red Hat OpenShift. There's a lot of kind of custom orchestration happening. So orchestration seems to be the key, and there's a lot of ways to interface with it. We actually had one of our engineers build a pretty cool Kubernetes dashboard for one of our customers that was kind of built with an extension and some log analytics that actually gives them a pretty cool view across that. So look to see us kind of build more visibility into orchestrators because it's a great way to understand the health and the status of all the different containers in an environment. So this is definitely a key area, but it's pretty painful to deal with this because you just have so many different layers. Like we have a physical system, we have a virtualization, we have the containers, we have the orchestration, and then there's the apps and everything else on top of it. How do I manage that stack? It's really painful. So you really just end up with a really disjointed set of tools and technologies and visibility. And you can't go to a vendor. I mean, I'm not going to tell you AppDynamics manages everything from top to bottom in there. It's really hard to manage all those moving parts. But the idea is the application that's on top of all that infrastructure is something that we can monitor and measure so that we can isolate a problem to a component. And that's really the key of what we do that makes it a bit different, is that by monitoring at the app layer, you don't have to constantly deal with shifting tools that are going to continue happening on this stack. So it's pretty tricky. We're going to go into a little bit more about the future and where containers and orchestration are going. So this is a Docker survey, specifically state of the cloud. The interesting thing is that you see here that Docker is a key part of most people's strategy. And they plan to use it to containerize and migrate workloads. So the idea is, if I want to move things between private cloud and public cloud, if it's in a container, it's easier to make that portable. We can orchestrate it much more easily. So you can see we're kind of on the precipice of having a real hybrid cloud strategy. If I can package things and move them, and they're generally self-contained, then it makes things far more portable. I can move things between data centers much more easily. And it's really about being portable and avoiding the lock-in. So a lot of folks that are building this container orchestration may be building it on top of AWS. So you ask, why don't they just use the native AWS container management? And it's really that people want to avoid that lock-in. They want to say, if Google Compute Engine starts to become cheaper and faster, I can just move my whole orchestration layer over to that platform or include it in the existing orchestration. So that's really the key thing that people are looking for, is really this hybrid orchestration, the idea of making everything portable and moving between these different environments. The other cool thing that started to emerge is from HashiCorp is Terraform. We use it a bit to manage our SaaS environment. How many of you use Terraform? Oh, there's a couple. And how many of you have heard of Terraform? A bit more. Okay, cool. So the idea is that Terraform can build a virtual infrastructure across clouds in a uniform way. So you basically define, these are my load balancers, these are my hosts, these are the basic constructs of a cloud, and you do that in a config file. The interesting thing is Terraform's just a binary. It reads the config file, it has APIs to interface with Azure, AWS, it deals with other private cloud infrastructures, and it just builds that out so that you can deploy the same environment in terms of your infrastructure in an agnostic way. It's pretty cool technology that they built. It's open source, they have a commercial version as well, but most people just use the open source. So it's rather agnostic. The other piece is they can provision the orchestration layer easily, so it makes it fast to stand up new environments, to test things, but then you use it in production as well. So how many of you are doing a PaaS or a private PaaS like Pivotal Cloud Foundry, Red Hat OpenShift, Azure Stack? So quite a few. So the real question, and I think the next thing that we're going to have to start answering, is whether this type of technology can replace a lot of what the PaaS does. Why do I need all the complexity of a PaaS when I can automate and orchestrate a lot of this as long as you're in containers? So I think what you're going to start to see is almost like a conflict between a PaaS and whether I'm going to build an orchestrated container type of environment to deploy and scale my application. So it's going to be an interesting conflict. I mean, they're both rather complicated systems, just having all the moving parts, but they definitely are becoming more similar and similar with every release and as things move. The other piece that I wanted to kind of talk about is the complexity in IoT and connected systems. What you're seeing is a very diverse set of technologies that are continuing to exist, and not a lot of standards, not a lot of common APIs across these different systems. And so as you kind of scale out the different applications and use cases, it becomes pretty hard to manage all this complexity and diversity. And I don't really think that this is going to change anytime soon. It just continues to get worse and more complicated. The other problem is it's very hard to get common analytics across this data. So if I'm trying to make a decision and I have my environment deployed on a PaaS, infrastructure as a service, I have container orchestration, how do I really analyze that data and make consistent decisions across it? It's a real challenge. And I don't really think it's going to change anytime soon. The other thing with IoT is that you see a big fragment. How many of you actually have IoT systems today? So there's like 2 or 3. The other problem with IoT is that a lot of this ends up being managed by what I'll call the business. In many cases, it's the facility side, the business side that actually owns a lot of that data. And it's a big challenge because IT is really responsible for a lot of the IoT capabilities in terms of connecting it out to the public world, but in many times it's really managed internally by the teams. So what we've seen as we've worked with our customers where they use AppDynamics and IT, we have to actually get introductions into their teams that manage the OT, the IoT side of their business. And making these connections is difficult. They oftentimes don't even talk to each other. So they don't know what the other team is doing. It's pretty fascinating to see the silos within IoT. And this is just going to continue. IoT is going to start affecting a lot of our businesses. I don't even want to go down the rat hole of security in IoT because that's a whole nother ballgame. But just getting the teams to work together is a big challenge with this isolation. So I'm going to start talking about some open source, some other solutions for some of these issues, some of these problems. The first issue that you run into is scale, and just generally, how do I manage all of these systems? So back in the day when we had a server, we could put 50 VMs, or we can put 50 VMs on it. But now we can put 500 containers on that same type of system. So if you think you had server sprawl when it was up here, the container sprawl is far worse because these are very small components that can be moved easily. And the other issue is as you layer these in, and a lot of people do run containers on VMs, which obviously are running on physical systems, is that each layer introduces new tools and new views and new data. So this problem is just getting worse as we abstract, even on the infrastructure layer. So you end up with just so many tools out there to try to solve your problems. And every time you introduce a new technology, whether it's open source or commercial, you're going to have another tool. And that tool is going to be designed for a specific user of a specific technology. And so you just end up with this massive amount of sprawl that's very depressing. The other issue is that the graphs that we use and the dashboards and views, I know everyone loves dashboards, they're just not really scalable. The analytics are done by you. Can you interpret all these lines and charts and graphs and figure out what's going on? But in reality, when we talk to our users, they ask for more lines and graphs and charts. So as a vendor, how much do we invest in building lines and graphs and charts? And how much do we invest in actually building real computer analytics? And that's the challenge that we face, is that our industry loves lines and graphs and charts, even though they don't scale and they're very hard to use in general, because you're doing the analytics, not the computer. The other piece that we've seen happen just in the last couple of years is that AI is becoming far more intelligent. So I like this graph because it really shows how good computers are at recognizing images. And as you've seen in the last couple of years, it's basically gotten as good as a human has, just in analyzing visual data and pictures. And this is really where we've gotten to today in terms of just having the computer technology to be able to do this type of thing. So instead of you analyzing the lines and graphs and charts, we can have computers do that for you and do it very accurately and obviously much faster. The other thing is that AI, and Gartner talks about AI ops, which is basically applying these new artificial intelligence technologies to both monitoring, service desk, and automation. and building a closed loop system. This is what I would call forward-looking, meaning there aren't a lot of vendors that do this, even though a lot of them say they do. But the idea is, how do you connect all of this data together and actually have more automation that happens on its own? And I think in the next year or two, we're really going to get to the point where these systems actually do interoperate and work. I know one of the partners that we work with that was obviously announced yesterday, ServiceNow, is doing quite a bit in this space. So we're excited about being able to feed them data and help them, help us both automate a lot of this life cycle, so to speak. And that's really the vision that we see happening, is how do we connect these pieces together? And it's not about one product that does this, it's how do you interoperate and build this type of ecosystem and analytics around it. So, I do think that there's hope to making this much easier than it is today, but we're still a little ways off for sure. And so that wraps up. I have about 10 minutes or so for Q&A. And please review the session, and you can win an Alexa. And thank you very much for joining. Any questions I can take? I'll just repeat it if you. Anyone? No? One here. All right. So the question is anyone using quantum entanglement to get around the CAP theorem? I can't answer that question because I don't know enough about quantum entanglement, but I'm happy to talk to you after about that for sure. What I will say is that future thinking-wise, in terms of what we want to do at AppDynamics, is we obviously have a lot of great data. What I would like for us to be able to accomplish is building new types of capacity planning and capacity management based on application data instead of infrastructure data alone. So I see that there's a real gap in the industry in general where we capacity plan infrastructure silos today, and yet we don't understand the impact of the application or how to capacity plan applications. I think with the data that we're gathering and as we go deeper into infrastructure, we can solve some of these problems and link the things together. And I think that will be really exciting when we can modernize capacity planning and really turn it into a different type of science than it is today. Question over here? Sure. So the question is, I touched on machine learning and artificial intelligence and how's AppDynamics, what is AppDynamics doing there? So what you'll see from us coming at some point is the ability to do automated metric analysis where you can see which metrics are moving together. So you'll see us kind of highlighting how metrics move together and how they may be related. The other thing is we look at the metric path. So in AppDynamics, when you think about the tree and metric browser, we take that metric path and we also analyze that. The other thing is in log analytics, we're doing a lot more automated analytics in that. So how do I automatically extract patterns and collapse down similar events and provide views like that as well? You'll also see later today some of the things that we're doing around automated root cause analysis. So that's part of the keynote that will be right before the party tonight. You'll see some of the new innovations that we're doing, and automated root cause analysis is one of those. It's a pretty cool demo and something that we're really excited about bringing forward as we think about real unified monitoring across all of our data. Other questions? Well, thank you very much, and you have 10 extra minutes in your day.